Welcome back. In this video, we'll be looking at example 1.2.3. I'm going to prove that the subset of diagonal matrices, so this D here, I'm going to prove that this D is the subspace of M22. Remember, M22 is the vector space of 2 by 2 matrices under the usual matrix addition and usual scalar multiplication of matrices. All right, as we did in the last problem, we'll show the three properties. All right, first I need to prove that the 0 of M22 is in our subset. So 0 of V in this case, the 0 matrix was the 0. I could write this as a 0, 0D, where I was allowed any A and D and R, so that means I'm allowed to take A and D to be 0, and so 0V is in D. All right, second, I need to take two elements so A is equal to, actually, let's call them A1, A2. That way the notation is going to come more naturally. A1 is going to be A1, D1, and A2 is going to have A2, D2. Right? I need to prove that the sum is also diagonal, but if I take the sum, I'm going to get this, A1 plus A2 and D1 plus D2, which is in D. I just have to take A to be A1 plus A2 and D to be D1 plus D2. Perfect. I'm up. There's only the one condition left. I have to take one matrix and a real number and see what happens when I multiply them. So let's take A1 in D, and let's take K in R. I'm going to have to look at K times A1. That's going to be K A1 0 0 K D1. And though this is still a diagonal matrix, I have A equals K A1 and D equals K D1. All right, so we proved that 0 was in D. We proved that the sum was still in D, and we proved that the scalar multiplication keeps us in D. And so by theorem 1.2.1, D is a subspace of M22. That's it. All right, so we'll do one example with functions in the next video, and then we'll start looking at things that are not subspace. And that's kind of fun. I find those problems really cool.